Hello, everybody, and welcome back to physics class. Today, we are going to be talking about forces acting on objects that are on an inclined plane. So let's just take this example right here. We have a car that is parked on a hill, and this hill has an angle of theta. And we know if we were to draw the free body diagram that the force of gravity pulls down like so. We know that the normal force is perpendicular to the surface, so it's going to be upwards at an angle like this. And we also know that there is friction force that is preventing the car from going down the hill, so the friction force is going up like this. Now, when we try to find the resultant force acting on the vehicle at this particular point, it gets a little tricky. You see, this is an incline. It's no longer a flat surface like we would have with like a normal situation. We have to worry about the angle now. So the first thing that we need to really do is identify our axes. So here, this axis right here, we're going to consider this to be our x axis, which is similar to this one right here being the x axis. Then we are going to establish this axis right here that is going through the normal force is going to be our y-axis, similar to this axis right here being the y-axis. So that's the first thing that we need to do in order to establish how these forces react with each other. Now, the second thing that we need to do is we actually need to look at our gravitational force right here. So if you see, our gravitational force is no longer parallel with the y-axis, meaning that our gravitational force is now at an angle. There are two components. There is the horizontal component, which is what's pulling the car down. This is the force that actually pulls the car down. We call this FGX. And then you have the component that goes into the incline at the same angle as the normal force. And this is the FGY. So we have to break up our gravitational force into these two different components. This means that we're going to have formulas for these two components. FGX is equal to your force of gravity times the sine of your angle theta. And then FGY, which is this one right here, is equal to your gravitational force times the cosine of your theta. Now remember, these are only when you have an object on an inclined plane. This isn't applicable to when it's a flat surface, because then your gravitational force is parallel with your y-axis and you don't have to worry about this. Now, I had said that this car is parked, meaning that it's not moving. That means that this is actually in equilibrium. So if I wanted to find the equilibrium forces, then I would know that my normal force is equal and opposite to my FGY. So Fn is equal to the negative of FGY. Now, when I go to find my friction force, I know that it is equal and opposite to my FGX, which is the force pulling the car down. So friction force is equal to the negative of FGX. So these ones right here are for equilibrium problems. Now, let's take a look at an example. So here we have an object that is rolling down the hill, and it is rolling down the hill at a constant velocity. So this means that we are in equilibrium, and this object has a mass of 100 kilograms, and the angle of the incline is 40 degrees. We want to know, what must the force of friction be for the block to be moving down the hill at equilibrium or at constant velocity. So what is our kinetic friction force in this case? Well, the first thing we want to do is draw our free body diagram. We know that gravitational force pulls down. We know that the normal force is moving up at this angle. And we know that our kinetic friction force is opposite the movement. And since this is rolling down the hill, it's going to be going up the hill. We also know that the gravitational force splits up into two forces. We have the FGX here, and we have the FGY right there. Now, we are only concerned about our frictional force right here. So we're not going to worry about the normal force or the FGY. We're only going to worry about the FGX, the FG, and the FK. That's all we're going to worry about. We're only going to worry about these ones right here. So first step is to find our gravitational force. So the gravitational force is your mass times your gravity. In this case, it is 100 times negative 9.81, which gives us a total of negative 981 newtons. From there, we're going to go ahead and use the formula FGX is equal to FG sine theta. So FGX is equal to negative 981 times the sine of 40 degrees. And that will give us a total of negative 630.6 newtons. Finally, the last step is to find our FK. We're going to use the formula FK is equal to the negative of FGX, which means that our friction force, our kinetic friction force, is equal to the positive 630.6 newtons. So that must be the kinetic friction force acting on this ball in order for it to be descending at a constant velocity in equilibrium. Thank you for listening, and I will see you all next time. Bye!